Let's talk about cross product or vector product. The cross product of two vectors yield a vector that is perpendicular to the plane formed by the original vectors. For example, here we have a vector A and vector B. We form a plane passing through these vectors, and we can say that the vector C is perpendicular to both of them. The result vector, or the cross product, is a vector perpendicular to both of them, perpendicular to this one and perpendicular to this one, or we can say C is perpendicular to the plane passing through the two initial vectors. The magnitude of the cross product is given by magnitude of A times magnitude of B times sine of theta. Theta is the angle between two vectors A and B. Okay, if we want to calculate the components of the cross product, we can find it like this. We can find the determinants. The first row are I, j, k. The second row are components of A vector. The second row are components of B vector. It's not necessary that A and B will be three-dimensional. If they are two-dimensional, we put 0 here, no problem. Okay. No commutative property holds here. A times B, A cross B is not equal to B cross A. In fact, it's a negative sign applies here because the direction of the cross product will be applied by right-hand rule. And the reason for this is that sine of theta, sine of negative theta is negative of sine of theta. So, of course, cross product has no commutative property, and a negative sign appears if you replace the first and second vector. The cross product is 0 if vectors are parallel. If the angle theta is 0 or 180, sine of theta will be 0, and therefore the magnitude of the cross product will be 0. Therefore, cross product is 0 when the two vectors are in the same direction. Okay. An example of cross product in physics is torque. So torque is equal to R times F, or we can call torque also as moment. Let's talk about how we can find the direction of tau, or direction of the cross product. Direction of the result vector is found by right-hand rule. Okay, so the results of cross product is found by right-hand rule. Hold your right hand with your fingers spread out in direction of R, or four fingers of right hand in direction of R, first vector. Natural rotation of fingers in F direction, or so if you want to rotate the four fingers of right hand, it must show the second vector, or F direction. Then our thumb points in the direction of the cross product. So we can apply it here. You can put your hands. You can hold your hand so that four fingers are to the A direction, and then natural rotation gives B direction. Natural rotation of fingers gives B direction. Then thumb gives the C direction. This is called right-hand rule. The right-hand rule can be explained in many ways. This is one way of explanation, and it's quite handy. Okay, I explained it this way. Let's do some practice questions. Vector A and vector B are given. Find the cross product, A times B. We want the components here. So let me do it. A cross B is equal to the result of a determinant. Okay, I, j, and the second component will be k. First vector is 1, 2, 0, I plus 2j, no k component. The second vector is 2, 0, 3, 2, 0, 3. Now, how a determinant is calculated? I times a determinant formed by removing this row and this column. So I times this determinant minus j times a determinant formed by removing that row and column. Let me see. 1, 0, 2, 3. Very good. And then k times a determinant formed by removing that row and column. Row and column corresponding to k, of course. 1, 2, 2, 0. So we can write 6i, because determinant of a 2 times 2, determinant of 2 times 2 will be calculated product of the main diagonal minus the product of the other diagonal. 6 minus 0 is 6. Now here 3 minus 0, so negative 3j, and here 0 minus 4 4k. 6i minus 3j minus 4k. So first choice is correct.